So now that we have agreed on the units, we have the meter, the second, and the kilogram, we can start making measurements. Now, all important in making measurements, which is always ignored in every college book, is the uncertainty in your measurement. Any measurement that you make without any knowledge of the uncertainty is meaningless. I will repeat this. I want you to hear it tonight at 3 o'clock when you wake up. Any measurement that you make without a knowledge of its uncertainty is completely meaningless. My grandmother used to tell me that, at least she believed it, that someone who is lying in bed is longer than someone who stands up. And in honor of my grandmother, I'm going to bring this today to a test. I have here a setup where I can measure a person standing up and a person lying down. It's not the greatest bed, but lying down. I have to convince you about the uncertainty in my measurements, because a measurement without knowledge of the uncertainty is meaningless. And therefore what I will do is the following. I have here an aluminum bar, and I make the reasonable, plausible assumption that when this aluminum bar is sleeping, when it is horizontal, that it is not longer than when it is standing up. If you accept that, we can compare the length of this aluminum bar with this setup and with this setup. At least we have some kind of calibration to start with. I will measure it. You have to trust me. So I measure here 149.9 centimeters. However, I would think that so this is the aluminum bar. This is in vertical position, 149.9. But I would think that the uncertainty of my measurement is probably 1 millimeter. I can't really guarantee you that I did it accurately any better. So that's the vertical one. Now we're going to measure the bar horizontally, for which we have a setup here. Ooh, the scale is on your side. So now I measure the length of this bar. 150.0 horizontally. 150.0, again, plus or minus 0.1 centimeter. So you would agree with me that I am capable of measuring plus or minus 1 millimeter. That's the uncertainty of my measurement. Now, if the difference in length between lying down and standing up, if that were 1 foot, we would all know it, wouldn't we? You get out of bed in the morning, you lie down, you get up, and you go clunk, and you're 1 foot shorter. And we know that that's not the case. If the difference were only 1 millimeter, we would never know. Therefore, I suspect that if my grandmother was right, that it's probably only a few centimeters, maybe an inch. And so I would argue that if I can measure a length of a student to 1 millimeter accuracy, that should settle the issue. So I need a volunteer. 183.2, yeah. And an uncertainty of about this is centimeters, 0.1 centimeters. And now we're going to measure him horizontally. Zeg, I don't want you to break your bones, so we have a little step for you here. Put your feet there. Oh, let me remove the aluminum part. Don't watch out for this scale, that you don't break that, because then it's all over. Okay, I'll come on your side. I have to do that. Yeah, relax. Think of this as a small sacrifice for the sake of science, right? It's not. Okay, you good? You're comfortable? You're really comfortable, right?
Wonderful.
Okay. You ready?
Yes.
Okay. Okay. 185.7. Stay where you are. 185.7. I'm sure I want to first make the subtraction, right? 185.7 plus or minus 0.1 centimeter. Oh, that is 5. That is 2.5 plus or minus 0.2 centimeters. You're about 1 inch taller when you sleep than when you stand up. My grandmother was right. She's always right. Can you get off here? I want you to appreciate that the accuracy, thank you very much, Zeg, that the accuracy of 1 millimeter was more than sufficient to make the case. If the accuracy in my measurement would have been much less, this measurement would not have been convincing at all. So whenever you make a measurement, you must know the uncertainty, otherwise it is meaningless.